All right, well, welcome everybody to today's NEBP Speaker Series talk. I'm Susie Taylor. I'm at Montana State University in Bozeman. I'm part of the education team for the Nationwide Eclipse Ballooning Project. I want to say a huge thank you to NASA's Science Mission Directorate and the SciAct program for funding NEBP, as well as the NASA Space Grant College and Fellowship Program. We have almost 700 students all over the country. We have 53 teams. Most are at colleges and universities. If you're at high schools, I know everybody is getting pretty excited about the upcoming eclipse. We're just, wow, a month and a couple days out. So thanks everybody for being here. I'm going to turn it over to our special guest today, Jennifer Fowler from NASA Langley Research Center. I actually met Jen when she was here in Montana. We're sorry you left, but I know you've been on to super awesome things. So I'm going to turn it over to you. Thanks for being here today.
Thank you, Susie. And hello, everyone. I want to keep it pretty informal today. So if you have any questions or want me to clarify something, just go ahead and interrupt me. And if someone could just keep an eye on the chat, I would appreciate it. Thank you. I'm trying to do a split screen thing. We'll see how well I do with technology today. So you're seeing it in real time with my challenges. Whoa, and okay. And I'm having to share my slides a little bit different. So just let me know if you have a problem seeing anything. So I'll just start with who I am and let you know what my thoughts are here. I wanted to go through both my background, but also give you an idea of the history of how this program even came about. So I graduated from Rutgers University a long time ago, and I have a degree in physics. And what I did is I actually, right after college, I started working with the Forest Service as wildland firefighter. And then eventually I wanted to get back into physics, and I took a position at the University of Montana. And I worked in the Department of Physics and Astronomy there as a laboratory coordinator. So worked a lot with any laboratory that the department had, because it's undergraduate only. And then in 2003, I was introduced to this ballooning program, Borealis, which I'm assuming everybody is well familiar with at this point through NEBP. And at that time, I was still at the University of Montana. Borealis was started at Montana State University. And I want to point out the little circle that I have it says house divided. So anyone that's not from Montana, there are two large universities, University of Montana and Montana State University. And while they are rivals when it comes to sports, I like to think of it as a very close collaboration when it comes to academics and research. And I was definitely one of the, a house divided was basically, I have a magnet. I still have the magnet. It's on my refrigerator at home because I have a lot of affinity to both institutions. And so while I was at the University of Montana in 2003 doing the Borealis program, I was eventually introduced to the Montana Space Grant Consortium leadership team, and I joined them in 2013 on a more permanent basis, and not just under the Borealis program. So at that time, I became a Montana State University employee, so that near and dear to my heart. And I'll go into a little more detail on some of this stuff and how this flows. But then in 2015, I was asked to come back to the University of Montana and stand up an office called the Autonomous Aerial Systems Office, and that's a drone office. And I'll talk a little bit how that came about. And then in 2021, I took a position here at NASA Langley, and I'll talk more about that in the future. But I wanted to add that my most recent degree, I literally took this huge gap between my undergraduate and my master's degree. So I just got my master's degree in May of 2023. And it's in business analytics. So I went into the business school, and think of it as data analytics is the current master's degree that I hold. Okay, so let's go back to 2023 or 2003, sorry. I went on my first balloon launch. Montana State, the idea was to crawl, walk, run, fly idea that NASA has proposed. And this was an excellent platform to use balloons for the crawl part. Get students involved, just like you're doing with the engineering balloons, and design experiments and fly them to the edge of space. And the thing is one distinction we made is at the University of Montana, while we worked with undergraduate students, we primarily focused on middle school students. So the undergraduates would help the middle schoolers develop payloads. And I actually worked with that program clear through 2017. I just started to back off on my involvement with the larger balloons. Because I'm going to go down here at one point, and it was around actually 2007, I started to realize I felt very uncomfortable with my knowledge of the atmosphere. I realized we're flying these balloons, and this is super cool. We're doing lots of experiments, but I couldn't really answer key pieces of information about just a basic measurement like temperature. How accurate do you really need to be? What is the underlying theories behind the temperature profile in the atmosphere? And because I didn't really feel like I understood that very well, I started really diving into trying to understand it. And that led me to looking at radiosondes. So this picture here in the top right is it's a homemade radiosonde is what I'm going to call it, but it's called the Anasonde. It was actually developed by a company in Bozeman, Montana that I worked with. And the idea was, as I started researching about radiosondes and the type of information they could collect, could we make one ourselves? And that directly led to contact from, I got an email in 2011 from this guy here. His name is Thomas Lafon, and he's in the left-hand side, the guy over here. And he was getting his master's degree at the time, and he was down in the Colombian Amazon. And he was working on research involving climate. And the challenge with working in the Amazon is there's not a lot of data, atmospheric data, because particularly at that time, the satellites it was difficult to get the satellite data. It was very coarse data, it's heavy cloud cover. And the balloons, the interesting thing about the balloons, which I'm assuming everyone's pretty familiar at this point with the Wyoming Weather Web, because that's a spot that you can do both balloon trajectory predictions, but it's also a great source of data for radiosonde data. But if you pull it up, the default view is all the radiosonde sites in North America. If you look at South America, it falls off dramatically. There's much fewer sites in South America. But then you have to add on top of that in Colombia alone, I think there are 4 sites, at least there were back then. And the country would buy enough radiosondes to fly twice a day, every day, but then for one site. So they'd take that one group of balloons and they'd divide it among all 4 sites. So where we were in Leticia, Colombia, we'd get 3 months of data. And then the rest of the time there's no data. So Thomas really wanted to find a way to do cost-effective sounding. So I took a student with me who is also in this picture on the left, and that's Abby Thane. That was her maiden name. And she actually ended up getting her master's degree at Montana State University and her undergraduate at the University of Montana. And so we went down, we did a bunch of balloon launches, and then we came back and evaluated that data. And what we found is that, and as I'm skipping along, before I get there, I want to mention there's challenges anytime you do a field campaign. And one thing is when you have helium, it's difficult to get helium to a place that doesn't have roads. So we had to fly our helium tank from Bogota down to Leticia, and then this lovely little mule dragged that helium tank out to our field site in the jungle. So talk about challenges. Not only did we have data challenges with the sondes we were flying, but then we realized that helium was not going to be a long-term solution because that was not easy to find down in Colombia. So I went back in 2012, and backing up a little bit, when I was getting into the radiosondes, I wanted something cost effective. Well, I was also pushing that we evaluate some commercial radiosondes. So in 2009, started looking at the GRA radiosondes. So I think anyone that's in the atmospheric radiosonde side or the atmospheric sciences side for NEBP, you're flying the GRA DFM 17s. And I will tell you, I started with DFM 06s. So the numbers after are the years that they were developed. So I've flown the 06, 09s, and the 17s. So actually in this picture is a 06 that I'm holding in my hand there. And went back down to Colombia. And this time Thomas and I partnered with IDM, which is the Colombian National Weather Service. And they actually fly with hydrogen, not helium. They have a lot of water down there, and it's relatively easy. They have a machine that will pull out the hydrogen from the water, fill the balloons really quickly in a enclosed container, so we didn't get rained on as much as we had the previous year. And we did a field campaign down there. And during all our launches and through all our dinners, it was constant talk about how could we make this more cost effective and get more data down there. And that led pretty quickly into thinking about drones. So that's this picture on the top left. It's called the GPS Boomerang. This picture, the company that designed that was out of New Zealand, and unfortunately their manufacturing facility was destroyed in an earthquake around, I think it was around 2011, 2012. So we were hoping we could test something like that down in the Amazon, and we weren't able to. And the other thing I want to point out is that there was an article that came out of that. And so what I want to mention here and really, really emphasize is my interest in drones started earlier than this, actually, but I want to point out that I already started thinking about how do we do drones in atmospheric science. And I've always been interested in how to supply more data in data sparse areas. So, and I want to mention, because NEBP, I know that an ending point is going to be hopefully some publications. I'm just going to point out some publications along the way and try to let you know how long some of these take. That this one in particular, even though we did the work in 2012, that publication didn't come out for another 2 years. So 2014, and I'm going to tell you, 2014 was a very significant year in my life, and now all of your lives, because it led to where we are now. And I'm going to blame Angela Desjardins, and she's not on here, so I can blame her now because I hear I think she's in Africa at the moment. So moving on, 2013 came along, and I had the opportunity to join the Space Grant Consortium full time, and I jumped at that. So I just wanted to throw up some pictures about some of the things that are memories that are really near and dear to my heart. So the one on the left was a launch. We took a bunch of students down to Florida for the MAVEN launch of that, the Mars satellite. And then I want to point out in the top right, that is Chris Flynn. And I'm assuming all of you know who Chris Flynn is, because she is the grease that keeps those wheels turning. Chris and I, what kind of cracks me up about this is really one of my best memories. And yet, you know what we were doing that day is reporting for Space Grant. And reporting is probably one of the worst things you have to do and tasks in Space Grant. And yet, when you're with great people, you can always make something fun. So obviously there's a lot of food on this table, so we like to eat, but we also, we took a lot of walks. I have a picture that I decided not to completely embarrass Chris, but she did a handstand on that deck when we were working. Helps get the blood back into your brain after you've been sitting there doing some reporting. And I just can't emphasize enough how fun it is to have great coworkers. And then this bottom one is students. We would go around, as everyone probably knows, you go out to your different institutions. So this is at a tribal college in Montana, and we went out and did some work with those students. And I always found that to be one of the favorite things for me to do. So 2013 rolling along, everything's great, flying some balloons, and then 2014 comes along. In 2014, just to bring up some memories, if anyone knows, 2014 was a big year for drones, because in 2013 the Phantom 1 came out, 2014 the Phantom 2 came out from DJI, and 2015 the Phantom 3 came out. And those were probably the earliest drones that were easy to fly. You didn't have to be a great RC pilot. You could get really great video. And I really leaned into that. And with having that background and working with the FAA through the balloon program, it really helped stand up that office at the University of Montana. So that's when I started talking about standing up the program there. But it really was established in 2015. And I want to point out this picture on the bottom right. This is it seemed to me a simple leap to go, well, those things are pretty cool and they can be reusable. How about we put a radiosonde on one? So this radiosonde sitting on this drone, if you can see it in the picture, that's a GRA DFM-09 radiosonde. And we were flying this up to 9,500 feet mean sea level near Glacier International Airport. And so that required the certificate authorization from the FAA to do that, required a chase vehicle. And so there's this helicopter sitting here. And the pilot needed someone to keep an eye on that drone the entire time. So we had a wonderful volunteer in the name of Dr. Cass Runyon from South Carolina Space Grant, came out to Montana and was our visual observer for this field campaign, which was fantastic. And we got a lot of wonderful data off of it. Obviously, the UAS don't go quite as high as the balloon. So depending on the science that you're focusing on, you might choose one over the other, or you might want to do both at the same time. So it's always in my mind, like, which platform should we be using? Coincidentally, in 2014, Angela had this great idea of, well, I remember her coming into the office and pitching this idea. What if we flew large balloons? So this is like the engineering size balloons into the stratosphere and streamed live video to a NASA website. And I believe most of us were like, she's crazy. But we've got 3 years. Sure, we can do this. There's the moment of like, oh my God, that sounds like a lot, but yeah, sure. Why not? We can make this happen. And I went right to, what kind of science can we do? And Angela said, yeah, let's get some ideas. What can we do? What science would be great during an eclipse? So like all of you have probably already started doing and have done, because the eclipse isn't that far away now, you're doing a lot of literature searches and you're looking for ideas. And you're also, I would think, you're noticing different authors consistently showing up. So pulling this back together, I want to mention that first article that I wrote out of the Amazon with Thomas. We published it in 2014, around the same time we were spinning up these ideas around the eclipse. And something I noticed about that when I was working on that article is I had a lot of questions about the atmosphere still, and a lot of questions about the history of instrumentation being flown. And when I was reading through all these articles and noticing names, one name consistently came up for me, and that was Dr. June Wang. And I reached out to her, cold email, just sent an email and hoped she would respond. And she did. And that was back in 2014. So that was back in 2012. So when 2014 came along, I was like, well, she was nice enough to answer my emails the first time. Maybe I'll ask her if she wants to do some science during an eclipse on balloons. And I reached out again. And literally these campaign objectives were the brainchild of Dr. Wang. So June is the one who really, I can't say enough what a great mentor she has been to me over all the years. And I'm still leaning on her consistently. And she said, let's focus on the planetary boundary layer. And I said, that sounds great. I've also had, I kind of question, like, when we take data, what do we do with it? So I've always been pretty interested in forecasting models as well. So this was added in, like, okay, if we get the data, we can do some analysis, we can publish a paper. Can we also ingest it into models and make it useful moving forward? And June was very supportive of that idea. She did say, I'm not a modeler, and a couple of us in Space Grant, some of the students and myself just jumped in and said, okay, we'll figure this out too. We'll learn a lot about modeling, particularly the weather forecasting research model, so that we could perform some assessment after the 2017 eclipse. And I want to mention now, it's during this time, we wanted to set up our objectives early. As we kept working over the next 3 years, we did recognize gravity waves would be really interesting, atmospheric gravity waves. So in conjunction, we were learning a lot about gravity waves, and the way that we designed the field campaign, which is this right here, we did go, well, we'll get some of the balloons to altitude that maybe we can detect some gravity waves. So that it was on our radar to consider it. It just wasn't the primary mission in 2017. And I want to note that you can see the way we designed the field campaign that summer. We looked across the eclipse, so the width. So we put 2 teams on the edges and 1 in the center. And we were flying balloons every 6 hours up until C1, and then we started flying about every hour. And what we know, and I'm going to go here to some of the pictures from 2017. This is Dr. Wang. Here's our center site with students. We were in Fort Laramie, Wyoming. We had actually large balloons flying. We had small balloons flying, everybody going to about the same altitude. We had a group right here, these two guys on the left side. I don't know if you can see my my mouse, but those two guys were with a program called Sent into Space, I believe was the name of it, and it was out of the UK, and they actually went even higher than any of us. So they went to 120,000 feet with a large balloon and took some 360 images. And it was this wonderful collaborations of multiple institutions. We and not only in Wyoming, but across the country, we had 12 teams that committed to working together. Although we weren't funded, there wasn't funding that tied us together. We still said, hey, we're all going to try to follow some kind of schedule and then work together to analyze some of this data and impacts. So the thing that we recognize, we came out with a paper. And again, I want to point out, we did the work in 2017. The paper didn't come out till 2019. So there's a little bit of a lag, but time, give yourself time and be kind to yourself, that when you're done with the Eclipse, you can be super exhausted and you don't want to look at data. Take your time. You'll get back into it. You'll get it done. Because it starts to get really interesting. And I'd say I always start to feel like, oh my God, I can't believe we pulled this off. This is really fun now as I'm starting to analyze data after I've gotten some sleep. The thing that we recognized is we didn't get high enough to detect anything, any absolute, we can say these are gravity waves. We actually terminated a number of our balloons early because we were so focused on the boundary layer and because we needed to deconflict our frequencies. So we recognized we hadn't achieved altitudes to get stratospheric gravity waves. And we were at a point that in our research, we felt that we could do the proper algorithms to get the parameters for stratospheric gravity waves. Tropospheric gravity waves present a little more challenge with overlapping wave fronts, and you've got some surface turbulence. So we just said, no, we're going to stay away from that. But boy, it'd be cool now that we know about these gravity waves. When's the next eclipse? And maybe we could go do that one. Well, it turns out, and as I'm talking, I'm going through the waves, and you all, I just realized I did have an animation on a slide. That's okay. Because you can see, this is just pictures of gravity waves. I mean, once you get into it, I don't know if you're all noticing that at this point, anyone that's working intently with the atmospheric gravity wave piece, that you're just going to start noticing them everywhere, and you start taking pictures of every cloud that you see, it seems like. So, and people will start sending you pictures before you know it, and they'll go, oh, I saw some cool gravity waves. But really what I wanted to point out in this picture, though, this graph, in 2017, there were gravity waves detected in the mesosphere during that eclipse with LIDAR, surface-based LIDAR. So where we wanted to target was the stratosphere. And during a poster presentation at the American Geophysical Union in late 2017, I had a program manager from the National Science Foundation approach me and say, well, this is pretty interesting. Are you thinking about the next eclipse? Will you actually try to do something with gravity waves? And I said, well, the next eclipse in 2019 is in Chile. It's in South America. But yeah, we'd love to go down there. And she said to me, we're doing measurements down there into the mesosphere for gravity waves. So how awesome would that be to co-locate your balloons in the stratosphere with our LIDAR in the mesosphere? And I said, I'm in. I mean, it's not hard to convince me to do cool stuff. So I was super excited. We ended up applying for funding. We got the money, and we went down to Chile. And we were just west of La Serena. I should have put a map on here. We were in the mountains it's south of the Atacama Desert, but it's in the area where you have, it's the Gemini telescope. It's down there. The Tololo telescope is down there, and we got to see a bunch of telescopes, so that was super cool. And we could see them while we were launching, and we were actually launching from Kolawara Observatory. And what we did is we launched balloons every hour. So the things we learned, we need to launch more often, and we needed to get higher. So we launched every hour for 24 straight hours that went through the eclipse. And this is the Smiley team on our last launch after everybody's completely sleep deprived. We camped camped in 2017. We camped in 2019. We made backpacker meals to keep ourselves going, and ate a lot of candy, I believe. There was a lot of coffee flowing. And ultimately, we had another paper. And actually, we turned this paper around relatively quickly because it was July of 2019 that we did the field campaign. We had our publication out in the late spring or summer of 2020. But we had we set ourselves up to do that. We had all of our algorithms ready to run. We knew what we were looking for. We even divided up our team. Like someone's looking at the background atmosphere. Someone's looking for the gravity waves. I mean, we were doing data quality, and it was just a machine, this group, to be honest, and pulling this off to turn things around as fast as we could. And so then it was, we put this out and we're like, that was a pretty cool publication. And then we sat down and said, to be good scientists, we only have one data point, and it matters, right? You can't just say, yeah, we did this. And so there's definitely gravity waves, eclipse-driven gravity waves. I mean, the theory says it's there. We found them. We're good. We're out. We're going to move on to something else. So we decided to say, we need to do this again. We need to replicate our results because that's so critically important. And that came to 2020. But the other big lesson we learned from 2019, don't take 5 people to do a 24-hour field campaign. It's not enough people. You need more people, and more friends is always good. So reached out to some people that I think you all know. Jamie Jacob, who is on this call, Matt Bernard, Sean Bailey, Susan Smith. Reached out to all of them and say, hey, would you guys be interested in forming teams, and let's go down to Chile again. It was a unique moment that we could have 2 total solar eclipses go through the same country with a year apart. So we made great plans. We had teams practicing all across the country. We're spinning up that we could have 4 sites, between 2 sites in Chile and 2 in Argentina. And then this thing happened that I think you're all aware of in 2020 called COVID. And that really put a crimp in our style. But this is not a group to be deterred by something like a global pandemic. So we forged on. And we did some, and please ask the people that worked with me. I mean, any of us will tell you all the hoops we had to get through to get down there. And what ended up happening is we did 2 sites in Chile. We couldn't go into Argentina. It was closed. Went into Chile. And instead of doing 24 hours worth of launches, we did 48 hours worth of launches. And we divided up our team. So the picture with the volcano in the background and the balloon, that's in Villarrica. So that's near the Andes Mountains. And so one group was over there, and then we had another group along the shore. And I just blanked on the name of our site. And it's due west of Villarrica. And this is our group jumping. You can see the OSU orange, I believe, is what's being worn here. Those of us from Montana learned this thing, the shooting, which I appreciate. I've got a colleague here that's from Oklahoma State, and I at least do my best to try to show some school spirit for them. And we came away with, I think it was a fantastic experience. A couple things we have a couple publications. One's still in review, but coming out soon. And I think it's this top one, and you'll notice some names here too. Eric Kelsey. And then down here, I put in the most recent AMS headline. That was from Ji Gong. And again, relying on people that know more than us, we reached out and said, we've got this data. Here's some ideas of what we think we'd like to do. Would you two help us with some of the analysis? So they jumped in on the analysis. And then, of course, when we're like, ooh, there's another eclipse coming in 2024, will you join the team? That was it was a no-brainer to ask everybody that we worked with to just come back again and do this with us in 2024. A lesson that stands out for me from 2020 that I want to mention. We had 2017 and 2019 completely clear skies. 2020, atmospheric river came through. So all of us were launching balloons in very wet conditions. And when the eclipse happened, we had pretty heavy cloud cover, and then it cleared up. So we had some really nice conditions after. But I want to mention this, and I was thinking about this the other day. Eclipses aren't just visual. I mean, you get all your senses involved. It's going to be, you're going to feel it. You're going to hear different things. You're going to see different things. And I'd even claim it smells a little different. And maybe it was the change in the, I mean, when you go from day to night, it always seems a little different. Just everything changes. So 2020, there was cloud cover. And I think at first, even I was feeling like, this is disappointing, but it is not disappointing. If you have cloud cover, you still get an awesome eclipse, in my opinion. I thought that eclipse in 2020 was just as impactful and phenomenal as the previous eclipses. And I'm saying this partially because for us in NASA Langley, we're going to Fort Drum, New York for 2024. And cloud cover is probably a high probability. And I'm still telling the team, it's going to be fantastic, because it will be. I mean, we're going to have a great experience. So thinking about this process as I've been talking, I just wrote out what the general process tends to be. We get this idea, we write a grant. You've already started to plan your field campaign if you're writing the grant, but you really need to nail down your field campaign once you get the money. You got to train for it, you execute it, you analyze the results, and you publish the results. And again, that time frame can take a while. I mean, from 2020, it was 3 years before we even published anything on the modeling side. And G is still working on some pieces, and we've got the other papers. So it's fine. I mean, there was a lot of data. That's the other thing. The more data you get, the more time you're going to take to analyze it. So this process is really critical. And I think understanding that process, even as a student, you may say, well, I'm never going to write a grant. You're knowing this process and taking in the information that you're getting from watching people go through the process is really important and really critical, and can help your career. Because I will tell you, by 2021, when NASA Langley reached out to me to offer me a position, that process is the reason that I was offered the position here. So my current title is Center Range Flight Safety Lead. And also I'm the UAS Fire Sense project lead for, it's a fire related project under NASA. But the key thing I want to mention here is our branch we're under Research Services Directorate. So we're a service organization. Anytime anyone at Langley flies a drone, we have range safety officers, and I'm one of those as well, where we go out with that project. And we perform the independent safety oversight that NASA has. I mean, safety is our number one mission, and that is definitely something we take very seriously. So the range safety officer does the safety briefs before any flights. So if you put it to balloons, we do the safety brief before balloon launches. And we do the reviews prior to getting out into the field campaign. And then we sit back and we're just kind of watching the operation. And I think of it as the equivalent. If you think of rocket launches, there's someone with their finger on that red button in case something goes wrong. That's what we are when we're in the field with our drone flights. And for the range piece, as my main position, our entire center is a flight range. It is set up to be a research area for UAM or AAM. So these are urban air mobility studies. And it's the idea that we will have drones in the air delivering packages and transporting people. So we have within Langley a test bed for that kind of research. And my position, I oversee the policy and coordination of resources and schedules under that range. So that's my current. Now I want to mention, I told you that I was interested in UAS and atmospheric development. So it was pretty quick. I was hired in the fall of 2021. So I literally within the first month, I was asked to do some atmospheric instrumentation flights with UAS. And I, of course, leaned in heavily to that because I was really excited. And I was going to mention, we're research services. So it isn't common that we consistently run projects on our own, but we're starting to do a little more project-based work. And I was asked to do a little more interfacing with the science directorate side and coordinate more between our UAS launches and the scientists. So and I love science. It's near and dear to my heart. So of course I was willing to lean into that. And we started with an acoustics flight test. We did these Learjet flights over a runway in Niagara Falls, New York. And in between those flights, we had to get atmospheric parameters. And so we flew an IMET sensor that some folks would be familiar with. Intermet makes radiosondes as well. And they also make a version that you can put on a drone. So we flew that in 2022. And then in 2023 for this advanced air mobility or urban air mobility research, actually at NASA Armstrong, we developed the payload here at Langley and flew it and tested it. And what we put on that was a GRA radiosonde. So it's a DFM 17. And sorry for the small picture. It's a little mount, it's a little T mount. We have the GRA radiosonde, and then we have an anemometer on the side of that. Once we got done with that testing, there was a wildland fire program. It's called ACERO. I have tried really hard not to learn all these acronyms, so I can't tell you what that means off the top of my head. Usually I get the first 2 letters and then I give up. I'll just tell you that it's a fire-related program. And we redesigned the mount, but it's the same system. We just keep refining the current system that we have. And because of that work, so ESD is Earth Science Division, and then Fire Sense is the program that I'm working with Wildland Fire. And they both said just a couple months ago, they go, hey, how about we give you some money to go make some measurements during the eclipse? So we are going to do that. And we're actually, again, we're going to Fort Drum, New York, because we didn't have a lot of time to put certificates of authorizations together for the FAA. So we decided, we looked at the eclipse path and we said, where is there restricted airspace that we could fly to higher altitudes? And we picked Fort Drum. And plus that coordinates a little bit with June Wang and the ballooning teams out there, because we are going to lean on the balloon teams from NEBP to give us some idea of what the atmosphere is doing prior to our launches of our UAS. So it's a safety case that we're going to stay away from clouds and rain and severe turbulence as we launch. So we're leaning on some of that data, and we'll be launching some balloons internally just to keep an eye on the atmospheric conditions. So that's where we are now here at Langley. And we're in the throes, I think, as everybody is on this call or on this talk, that you're all preparing for the eclipse. We're doing the same thing, going through lots of reviews to make sure our aircraft is airworthy, and make sure that Fort Drum has everything they need to give us the final sign off. And with that said, I want to remind everyone, enjoy your time. It'll go by fast. Work, you can get really tunnel vision in your work, but go out and get some ice cream. And I can tell you the top 2 pictures are from Montana. This is the last time I was out there to get ice cream, and the last time I got to go skiing. And then my bottom ones is just to let you know that you meet people along the way, and it's great when you don't lose touch with them. So this is Angela. She came out to see me within the first 3 months that I moved out here to Virginia. And it's lovely to have someone come out when you're feeling maybe a little bit homesick. So that it was fantastic to have that support. And then a couple of friends came to join me in Uganda this past summer, friends from Montana, just to do a big trip. And we hadn't seen each other in so long, and it was good to just take a break. So don't forget to smell the roses along the way, because this will go by pretty quick. And with that, I want to thank you.
And that was awesome. Thank you.
Absolutely.
Looks like Julia may have some questions that people have sent in, and I would encourage people to type their questions in the chat as well. We have about 20 more minutes. We can have people unmute and ask questions. So let's turn it over to Julia first.
Okay, so we had someone who submitted a question beforehand, and they wanted to ask if you had any experience with numerical weather modeling.
I do. So with the WRF program, NCAR, who actually built that model, they recommend that you come and take their week-long course. And I've actually taken that course twice. And then we did apply. I've run the WRF model off their supercomputers. I've run it actually off of NASA supercomputers before I got here. I don't have access now to that. I could, I just didn't get time to do that. So yes, I wouldn't say it's I can do some basic runs. I can get data out. I can do some analysis. I don't tend to get in the weeds and try to make any extra packages that go in the work program, but I can run what people send.
Nice. There's a question from Marissa in the chat. Do you have any advice for the NEBP students who now have lots of ballooning experience and may be interested in pursuing a similar NASA or ballooning/drone related job?
Yeah, I would definitely lean into talking about that you did a field campaign. It's I'm finding it really interesting because the number one thing that I've been running into here is and it's other NASA centers, because we've looked to we're still characterizing our aircraft and how high we can go and the batteries. And nobody seems very worried about the aircraft itself. They're always worried if we say, and we're going to launch some balloons right before that. It's just like, oh, balloons, scary. And yet, and this is even coming from groups that actually have ballooning teams. They do regular soundings. So one thing I would say is don't be surprised if you say, I did a ballooning field campaign. People are like, I don't think there seems to be one is either a fear or a misunderstanding of how balloon operations work. So my suggestion is when you're looking at a position, and I would assume someone doesn't know, unless you know they know something about ballooning, assume they don't know anything. And talk about really focus on the details that are not the balloon, everything that goes into it, the organization, the timing of events. I mean, something that's super unique, particularly about this Eclipse, is this field campaign, you can't slide the schedule. The Eclipse is not going to wait. And I think that is something that I'm noticing around here. People are like, oh, we can't treat this like it's a normal, oh, we'll slide the schedule a little bit and maybe we'll do our launches later. I mean, this has to happen on a schedule and on time. And I think focusing on the fact that you complete this and you've gone through it and you know how difficult it is to stay on schedule and on budget, to be honest, I would speak to that. You will be staying on schedule, and show them you've had that experience, because a lot of people don't actually have that experience. And one of the things we are really missing at NASA in general is program management skills. We've got a lot of people coming in with research and not a lot of dedicated program management, which is fine, because I think researchers can be good program managers too. And I think it speaks to your ability to organize both data and people when you've done something like this. So I would speak to that.
I had a question of my own, kind of going off of that.
Sure.
So we have a lot of students who are obviously in undergrad and thinking about grad school, and you have a really unique experience of taking some time off, getting a lot of professional experience, going back to school. Can you speak to like the value that you've seen in getting like a business analytics degree in lieu of something like more science related? You talked about the importance of program management skills, but
yeah, so I definitely there's a couple things that I've noticed. I think it's because I was in the business school that I bring up in projects, and one is definitely cost. So recently I've been really focused on particularly through our fire sense program, we're developing technologies and science to enable firefighters, both before fire start and during fires and after fires. And one of the things that I recognize over the years of being in fire, there's been a lot of funding put into technologies and into sensors. And the question is, why aren't they more widely adopted? And I think ultimately it's a cost question. And so I think cost benefit analysis are really important to do on any project. I mean, to really kind of think through, what am I getting out, and think about not just the dollar though. There you can attach dollars to the intangibles as well, and the benefits to other people that are involved in the project. So when I say cost benefit, I don't just mean dollars. I think having that perspective can be really interesting. Gantt charts. I'm actually working also with the NOAA's Hurricane Research Division, And one thing that we've been hitting hard lately are Gantt charts. So these are charts that give you timing and keep your projects on schedule. And I will tell you unequivocally, a Gantt chart was, I would have had to Google that for sure in 2017. I'd be like, I have no idea what you're talking about. It wasn't until 2018 when I was in the business school and you hear it all the time. And then I was like, oh man, that's a handy tool when you're doing projects. So it's the cross. I'm a huge fan of interdisciplinary teams. One of our students from 2020 was a biology major. One of our students from 2019 was a forestry major. I mean, we weren't always having just engineers or physicists or mathematicians. You know, when you think of certain things, or computer scientists, even. I mean, pulling in people with different fields really gives you some new perspectives of things you didn't think of. And I found that the business school really opened my eyes. To be honest, I'm going to be completely frank. I was a physicist. I made fun of engineers. I made fun of social scientists. And after I was in the business school, no way, no, do not do that. They work hard. There's some difficult analysis they have to do under very trying conditions because they cannot just have a spherical chicken in a vacuum problem. It is a challenge. So I think it gives you, stepping outside your comfort zone in the area that you're traditionally trained in really expands your boundaries. And I think that's a good thing.
Jen, you're our first speaker to geek out about Gantt charts. That's pretty awesome. We still have a few more minutes. If anybody would like to unmute and ask a question or raise your hand, we can call on you, or definitely use the chat if you'd like to. Jen, I did want to also say thanks for talking about the scientific publications. I don't think our speakers have talked about that previously, and I know it's definitely a goal for many of our students. So thanks for kind of walking us through the timing and the process of that.
Absolutely. I'm a big fan too. I think all the students should participate if they can in some publications.
Awesome. Jamie, do you have a question?
I do, and
Awesome.
obviously since we know each other, so I don't think I'm gonna try to ask you something that I don't know, which may not be the best question, but uh, how is your planning changed since you joined NASA as going from Montana State? What are you going to be doing differently, both good and bad? I'm sure there are a lot more onerous hoops you have to jump through in order to be able to fly, but what other advantages has it given you being at NASA?
I can tell you the quick advantage is we had no questions about going to Fort Drum. When we contacted that Army base, they said, you're NASA, you're in. Disadvantages are definitely the hoops. We have a lot of reviews. So every time, and I will give you an example, we are changing, we're going from a zip tie to put the Radiosonde in a container on our UAS to a set screw on another piece. And that we have to brief. We changed an antenna and we have to go brief. So our briefings are getting you can't iterate near as fast as you can at a university. I will say that. So I feel like we needed to start way ahead of when we started at the university, and we're starting way behind when we started at the university. So we're just heads down, and I've got a great team to work with here because everybody's pitching in. They know. I mean, we literally are doing a lot of paperwork right now. That's a whole nother talk to go through all the paperwork that we have to go through and the analysis. I mean, we do stress analysis on everything, including the balloon. We talk about part 101 and 50-pound test force to break that line. Well, we got to prove it. So and I haven't actually ever done that. I've never had to go through that process. So I think it's good. I'm learning some things. What I want, and I think could be advantageous, is we share this out. Like those kind of analysis that we do, I want anyone to be able to use that. We went through the process, go ahead and use it. So I guess that's how I would answer that question.
No, I think that's really useful. And I think if you look at it from an idealistic standpoint, we should all be doing that as part of our processes. We just tend not to.
I think there's a balance, and I'm not sure where that is yet. Maybe ask me after the eclipse, but there's got to be a balance between how we're doing this and how to iterate faster. And we're constantly talking about it. So I don't know that we're going to get there too quickly, but I'd like to find a way to make it a little bit faster, but also keep it really safe.
Thank you.
Yeah. Toll 10. That's where we were. That's the name I forgot. And I just need to see your face,
How could
Jamie.
you forget Toll 10?
I don't know. It just flew out of my head.
I hadn't seen the donkey picture before,
I
so
know.
I really appreciated seeing that one. I'm glad we
That's
did not have to do that. So,
everybody should have a donkey at some point in their life that's carrying something for them.
Hey, I did want to point out too, we still have a few more minutes, but if you need to leave early, Julia posted a feedback form in the chat. That'd be awesome if you could help us. This also gives you a chance to let us know if there's any other topics that you'd like to learn about in the NEBP speaker series. And please do let us know if you have any more questions. I think we still have 7 or 8 more minutes with Jen before you have to move on, I think.
It looks like there's another question in the chat. Marissa asked, what's next in your professional journey?
Oh, Marissa, good question. After the eclipse, I'm going to be pivoting pretty hard to operations on fires. So we're flying. I have till mid-October. There will be a window from mid-October to mid-November where we will be flying small UAS and large UAS on wildland fires with multiple sensors, and there will be crewed helicopters flying that are burning the area. And what was the other? I heard that there might.
Jen, I think your audio might have cut out for a second, or was that just me?
I lost her too.
Okay. Hey, Jen, we lost your audio.
Goes on for another 5 years. So
Hey, Jen, I'm sorry. We lost your audio about a minute ago. I'm really
Okay.
sorry about this.
no, I was like, I think I might be glitching. So fire is going to be my next focus, and it's the Fire Sense program. And my first thing is going to be a field campaign, and then follow on with that, we have multiple field campaigns, and we were going to have UAS on all those, and we have crewed aircraft, uncrewed aircraft, all in the same airspace. We're pushing to have beyond visual line of sight approval from the FAA to fly our UAS. So that's really going to be right after the eclipse. I'll be shifting hard that way into working on that.
Awesome. I have a question. If Julia, does anybody have a hand raised or a chat? If so, we'll defer over there. But Jen, you mentioned the sleep deprivation and running on candy and coffee and all of that. I think that was kind of a real eye-opener for our teams. A lot of the students are new to ballooning, and I think seeing kind of that tension and the emotions that can happen while you're in the pressure cooker. Can you talk to that a little bit? Like, this will be, the next big moment for a lot of our teams. How can people kind of cope with some of those high emotions and sleep deprivation and everything?
Yeah, I think there's a couple things that I'd say there. From the NASA side that I learned, and I wouldn't have used this term before, but it's a human factors issue. And we do hazards through those now at NASA. And what are those hazards? So, and that's what we're speaking to directly, that you have a lot of emotion, you're nervous. I mean, the number one thing that's going to get you through being nervous and some of that emotion is practice. Because you're just going to do it again. I mean, you'll get into a rhythm and you're like, I'm just flying this balloon again. The other key thing is the team. It's not just one person. One person is not going to make or break whether that launch happens or doesn't happen. Someone else is going to be there with you. And that's part of why you have a team, that everybody gets tired and they're going to miss something. So you're hoping you have a backup. You have two people watching the data, because if the balloon bursts early, one person might be so tired they don't notice. The other person's like, oh wait, hey, they'll hit you on the side and go, did you see that? So that's leaning on your team is really important. And something we talked about in 2019 is we had been together. It was such a small group, and we'd been together for so long at that point. We knew how to push each other's buttons. So when you get tired and you've got a sibling and you're like, I'm just going to irritate my sibling right now. We made a pact that we wouldn't do that. I mean, we just talked about like, okay, we know where those markers are when someone's getting tired or they're hangry. So we made a concerted effort to help each other through those times. Like, oh, okay, maybe it's not, and we had a shift schedule to sleep, and maybe it wasn't someone's time to go sleep. We'd give them that time. Like, clearly, it's fine, and we're not going to make fun of you. We didn't. Everybody was there pulling their weight. It was never a time where we thought, oh, they're not doing what they need to do. It's the moment when you get there and come together is to rely on each other, and sometimes that can be really hard. So I think some of it is an internal reflection of what, for you to recognize where your weaknesses are too, and where your pain points are, and when do you have too much, and how do you cope with those. For me personally, I love to exercise, so I like to go for runs, I like to go for walks. When you're in a field campaign, you can walk, you can do jumping jacks, you can do I'm thinking through I'm in karate. Like now I'm out in the field. If I'm feeling a little restless, I'll just start doing some of my katas, or maybe I'll do some of my kicks, and of course, that brings up stuff with all the young guys that are like, and I tell them, be careful, I might flip you soon. And humor is always a good thing too. Have some humor. If you like music, if music's something that you need, make sure you have your music device ready and stacked with everything that will calm you down when you're out there. So I think just deep breaths, rely on your team, practice. I mean, you've practiced. I think everybody there has been through the practice. You're good to go. You have a strong group that has already set you up for success. Lean on that group and lean on each other.
Awesome. Thanks. That's great advice. I think we are at the top of the hour here. So I do typically remind our students who are online that this speaker series is designed to grow your professional network. You now have a brand new person at NASA who's part of your network. Jen, would it be okay if any of our students have questions, if they reach out to you later?
Absolutely.
And if so, what's the best way to do that?
It'll be my email, and you want me to put that in the chat?
Yeah, that would be great.
Let's see if I can run my, okay, I just realized I need to stop sharing. Okay, there we go. I will put it in here. And I will be answering email.
Awesome.
And probably it'll be easier to get a hold of me. Yeah, if I'm a little slow, it's literally just assume I'm doing something with the Eclipse development, or I'm in a review.
Yeah.
Or we're looking
Awesome.
at data. So yeah.
Well, thanks again for being here today. We covered a lot of ground. It was really cool to hear the history of the Eclipse ballooning. I don't think a lot of our folks have heard that whole story unless they were part of it. So thanks again for being here, Jen. Thanks everybody for being here as well. Julia, do we have any last questions or announcements?
I think we're good on questions, but I did want to announce next week's speaker on Friday, March 15th. We're going to be meeting with Dr. Jamie Jacob at 4 p.m. Central Standard Time.
That'll be a good one.
All right. Well, thanks everybody for being here. Enjoy the rest of your day.
Thank you.